Hello everyone, welcome back to another video for the series. I'm InnoQ, and as promised I brought a problem from KMO. But usually when we say KMO, it usually refers to like the high school division in which I'm taking this November. But because I'm not good enough, I just brought a problem from middle school division, and it's still from stage 2, so it should be considered quite hard. I'm not sure if it should be classified as extremely hard, but I think this problem is quite classic, so I just brought it. And yes, so without further ado, let's start. So we need to find all triples x, y, z where they are distinct positive integers that satisfy this equation. So usually when we see this, I think we can rewrite, redefine our fraction. So what happened to my handwriting? Let a equals plus 1, b equals y plus 2, and as you probably have guessed, equals this, where a, b, and c are greater than 2. Yes, greater than or equal to 2. Then we have 1 over a plus 1 over b plus 1 over c equals, if you calculate this, 3 over 6, 2 over 6, 5 over 6, 11 over 6, and 11 over 12. So it equals 11 over 12. Now here, if we find the value of a, b, and c, then we're just done. But notice that we can swap our variables here. So it's totally fine to say, without loss of generality, let this be true. And again, it doesn't really matter, because we can say that this is equal to b, this is equal to a. We anyways have the same equation, and we can just rearrange them, this one, so that it just fits. Yes. Let okay, so here we know that because a is the greatest, this one is obviously what? This one, 1 over a plus 1 over b plus 1 over c. This is equal to 11 over 12, and it's obviously and this is equal to 3 over 8. Now here, notice that if c is greater than or equal to 4, a contradiction occurs, because 11 over 2 is greater than 3 over 4. Meaning c can either be 2 or 3. Therefore, our first case is when c is equal to 2, because of this. Second case is when c is equal to 3. So we have 5 over 12, 1 over a plus 1 over b equals 7 over 12. Now we just need to solve for a and b. And so we have 12 times a plus b equals to 5ab, and similarly we have 12 times a plus b equals 7ab. Now I think we can use Vieta, but I don't think Vieta will be that helpful, because it's quite hard to determine all possible solutions here. So what should we do? Let's use Simon's favorite vectoring trick. So we have 5a minus 12 and 12. Oh, 5b. 5b minus 12 equals 144. And I'm quite lazy, but we need to do it. Because a and b are positive integers, it's obviously... Can this be negative? So like negative 12, negative 12. That should not work. Yes, so 144 doesn't... Oh wait, how many factors does this have? It's 12 squared, so 2 to the power of 4. Wait, we have to try 15 cases. But anyways, it will be symmetric, so we need to only test 7 cases. So, not that bad. Wait, what do we get? What? 46? No? Should not be 46. It doesn't make sense. 23 does not divide this number. 40, we have to... What? 26. Oh, 8. Oh my goodness. It's 12 times 3, so 36. 5, 6 is 24. I think I accidentally swapped them, but doesn't really matter. 8, 9. We have 9 and 16. 10, 11, 12, and 12. The reason why I said I made a mistake is because I accidentally swapped their position. So this thing should come here. Is it right? Because B is smaller, right? Yeah. So like this. Now let's test them. This doesn't work. Doesn't work. This does work. So A equals... I'll just write them in pairs. 12,3. E doesn't work. Doesn't work. This one? It works by 6,4, I believe. Is it right? Not sure. I think it's right. Doesn't work. Doesn't work. Let's do the same for this one. 7. The number's bigger. I love it. Oh wait, actually? Oh, it's great. We can just copy like this. Oh, nice. See if we can do this. Nice. Let's see if this works. Does not divide. Maybe this one. 84, so 12 and 2. This one doesn't work. Doesn't work. Doesn't work. Doesn't work. Does 28. So 4 and 3. This doesn't work. And apparently this doesn't work either because C is supposed to be less than B. Less or equal to B. Okay, so we have, let's say, for triples A, B, C, we have 12, 3, 2, 4, 2, 6, 4, 2. What's our next number? 12. Oh, wait, that doesn't work. 4, 3, 3. Okay, then do you need to try every case? I'm assuming we don't have to. Yes, I don't think we need to try them. So, wait, maybe we have to. Then we will have like 6 different cases and don't want that. It's 11, 1. Oh wait, this obviously doesn't work. Okay. We actually do need to try a different case. But let's just then change these, like CBA maybe. Maybe that sounds a little more. Maybe. So if we but I don't think we need to count other cases if we do this. Because like think of it like this when we no I don't think we really need to try other cases when like this is equal to B, this is equal to A, this is equal to C, and that's because we know that 1, 2, 3 differs by 1, and A, B, and C must be different from each other. Okay, but but I think we don't. Wait. Because we have 6 cases from here, from each, so we need to test 18 different cases. And that doesn't look pretty. That's why. Okay. Let's just try them. Oops. So we have 1, 2, 3, 4. I will just list them. So it should differ by 1, 2, and 3. So 1, 2, 3. So the first case that we can have is 11, 1, 1. So wait, I think I need to write them. Wait, I think A, B, C. I'm confused. I need to write them. A, B, C, X, Y, Z, X, Z, Y, Y, X, Y, Z, X, Z, Z, X, Z, X, Y, Y, Z. Okay, so this was our first case. Obviously it didn't work. Next one is this one. So 11, 1, oh wait. So we are assuming that but we still need to change the position of X, Y, Z. I'm sorry, one last change. I think it will be just more. I think it will be more clear just to do them right away from here. So sorry about issue, because we didn't like have this issue in the official solution. 2, 3, just in case like ABC swaps here. The next one that we can have 2. Next one is 2, 3, 12, 12 and 3. Next one is 6, 4, 2, 6, 2, 4, 4, 6, 2, 4, 2, 6. This is painful. 2, 4, 6, 2, 6, 4, 4. Oh, this is nice. We only have 3 for this one. But obviously we know that we don't have to test this one, but I will just do it for clarity, but for the sake of explanation, but we don't have to do this because these differ by 1. So oops. Yes, so we're not thinking about without loss of generally this one here, because we're thinking about these things swapping each other. So our main points are this one, but we still do need to try other cases just in case. So like the one that I highlighted are like the actual a comma b comma c, but I'm writing this so that we can rearrange, we can get different values we can get different triples of x comma y comma z. So for this one we have 9 comma no, let's just keep it original. But the reason why I'm ignoring my case without loss of generality, this one, is because I don't think this will significantly affect. We might get different cases for, yes, because like I mentioned when I was writing without loss of generality, this one, we still didn't need to consider the case when we swap them. So this is just expansion of like not generalized one. I think that's like the best explanation. You know, this doesn't work obviously. 11, 0, 0, this doesn't work. 2, 0, 9, this doesn't work. 2, 10, -1, this doesn't work. 1, 2, 3. So 1, 2, 3 doesn't work. 1, 2, 3 doesn't work. So these doesn't work. These just doesn't work. 1, 2, 3 doesn't work. 1, 2, 3 doesn't work. 1, 2, 3 doesn't work. Wait, do we even have a solution? 2, 3 doesn't work. Oh, just 3, sorry. 1, 2. Oh, nice. Finally got something. 1, 2, 3. It doesn't work. And these obviously we don't have to test them. 1, 2, 3, 1, 2, 3, 1, 2, 3. Yes, these just doesn't work. So apparently our only solution is this. Yay. And that turns out to be correct. So yes, I think there are multiple cases for this problem. I mean, this is too brutal. Like, this is only problem number 1. and they're giving this to middle school students. Okay, so our first kick is like simplifying this. Second one is considering this like, so but this part is quite tricky for me because I just wrote this without lots of generality, calculated like this, but the reason why we had to expand them like or permute them is because we don't know if x is the greatest. It might be z that's the greatest. So that's why that was one issue. And yeah, other than that, wait, now that I think about it, if we let this equal c, this equal b, this equal a, then we could have just directly find it, because we can say that without lots of generality let z, yeah, I think that still works. Like saying that without lots of generality let z greater than y greater than or equal to x, and that should not cause a problem, because otherwise, like if we write x is greater than or equal to y greater than or equal to z, then like the 1, 2, and 3 might neutralize that, so that might be a problem. But if we just swap them, then it wouldn't cause a problem like what we found here. So we could have avoided brute forcing that way. Yes. Okay, so I think this problem was pretty nice. I enjoyed this problem. I'm quite worried about the high school division because I was not able to solve a problem from middle school division. And yes, good luck everyone who is preparing for Med Olympiads and competitions. And thank you so much for watching this video, and see you tomorrow. Bye.